Hello everyone, welcome to Model Matrix Building Information Modeling, where I try to explore several aspects of it. So if you have interest on BIM, then you can follow us and subscribe to my YouTube channel. Alright, I have already published a video where I parametrically modeled a two-story building, and that model, it included structural and architectural both part. In this project, I'll be modeling a three-story building, and in that modeling I will be emphasizing over the structural discipline only. Structural discipline means I'm going to model the structural members like the beams, columns, slabs, foundations. These members, they are responsible to bear the load of the structure. And as you all know, modeling in Revit, it's all about placing the families in their proper position, right? And I'm presuming that you have prior experience with Revit and families. Then you must know that families, these are like building blocks of your project. And from that aspect, today's modeling can be fragmentized into 5 parts. In the first part, I will be showing you how you can model the geometrical shape of these structural members. This segment can be named as the concrete part. Second part, I'm going to show you how you can fabricate the reinforcement beneath these structural members, how you can detail the reinforcement inside these members. And in the third part, you're gonna see how do I annotate and tag all these members and elements I just created in the first part and the second part. To make them more understandable, you need to tag these elements and the members, right? All right, fourth part, I will be focusing over the material scheduling. In that part, I'm going to show you how you can make a proper material quantification report, and from that report you will have a proper perception about how much amount of materials will be required to accomplish the entire project. Fifth part is the coordination part. Using some Revit tools, I'm going to show you how you can coordinate the project. How much amount of work were being executed in the field. You can track them down and mark it to your 3D Revit model, of course using some cool Revit tools. And I'm gonna show you all these things in that fifth part. That is the brief summary of the project I'm about to accomplish right now. And I think it's going to be a very helpful project for you if you have interest. If you have that enthusiasm on BIM. After watching that project, if you watch it completely, then you will have a clear perception about the structural modeling in Revit. All right, everyone, as I mentioned earlier, that the entire project will be fragmentized into 4 parts. So I'm here with the first part. It's the concrete part. Here I will be modeling the concrete elements, the geometrical shape of the load. So combinedly, these concrete and steel, they work together to resist the load of the structure. Okay, these are the structural things. The structural engineer, they are supposed to responsible for the structural design, but I think as a modeler you should have some knowledge about this design procedure and parameters, so that if you see any anomaly or anything wrong, you can discuss it with them so that they can make modification or changes to counteract the anomaly or make you perceive why did it happen. Okay, I have opened the Revit software, as you can see. So yeah, let me start my project. Underneath the models option, I want to choose the new, and let me choose the template. Here we have bunch of templates. I will choose the default one, It's going to be a structural modeling, right? So I can choose the structural analysis template, but I am presuming that you people are the beginner with Revit. So as a beginner, I think it's a good idea you start with the default template. Step by step, you're gonna see the other templates. Okay, so let me choose the default one. Okay, right, it's taking some time. Yeah, you can see in the properties palette we have a bunch of instance parameters, and underneath that properties palette we have project browser palette, and through this palette you can travel to any particular plan, whether floor plan, ceiling plan. All right, it's going to be a structural modeling, so I think I need to add the structural plan, and in the view option you can see plan views. Okay, structural plan. Yeah, so the structural plan has been appeared in my project browser palette. Okay, I want to make some project parameters. Here I'm gonna make two project parameters. One will be concrete member, and second parameter will be rebar location. And through this parameter I want to dictate over the visibility of my entire project. I can control the visibility of each and every individual element through these parameters. Not only that, these parameters, they will also help me when I will make the material quantity takeoff report. So you're gonna see these things. So in the manage ribbon you can see the settings panel. I'm supposed to choose the project parameter option and new parameter. The first will be the concrete parameter. And yeah, the discipline I want to keep it common. Data type will be text. Type or instance values are aligned per group type. Okay, now the filter list. I supposed to choose the category. I want to choose structural and architectural both category, and I want to check them all. Okay, another parameter, and I want to name it as rebar. Rebar location. So the rebar location parameter, data type text, no doubt, and here I want to choose the structure only. And in the subcategory, under structural disciplines, the structural rebar. Okay, that's it. Two parameters have been created. Yeah, as you can see here, the concrete parameter, that name, I think I want to change the name. It was a mistake, right? Concrete location. Concrete location. River location. Yeah. Yeah. So the concrete. Oh God. Concrete location. Sorry guys, my typing is skill it's pretty horrible, as you can see. Okay, so I have created the parameters, the project parameters, which I'm going to use in my project. Now I want to make some levels, and how much levels there will be. To determine the number of levels, I think I need to choose the plans, how much plans are available right here. Yeah, I have another computer screen right here which I use to look over the other files or plans. Yeah, here it is, I'm showing you. So if I look down there, yeah, don't take it in other sense. Okay, alright, these are the plans are available for the project. You can see FL for floor plan, TB for tie-beam plan, SOB, slab on grade, first floor, second floor, third floor plan, roof plan, and top roof plan. So in total we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 plans, right? And for these 8 plans, I supposed to make 8 levels. Each and every level will be corresponded to a particular plan, to a certain plan, of course. And here I'm gonna create 8 plans. Okay. I have opened all the plans, the PDF copy of all the plans. Alright, I have opened it. Now let me make the levels. To the north, I want to start from the north. And let me take a look over the elevation. So what will be the elevation of these levels? I'm gonna find it out from this plan, from this elevation plan, as you can see. So okay, the 0, 0, 0, 0 level, there will be slab on grid. Slab on, not grid, grade. Okay, grade, it defines the plinth level, of course. And what is plinth level? Plinth level is the level where you will place the first floor of your building or your house, right? Okay, architecture ribbon and the datum panel, I supposed to choose the level option, and I want to choose the peak line and the offset. One offset will be 150. Okay, I think I forgot to define the project unit. Project unit U and the shortcut. What is it? Alright, UN, and the length, I want to choose the meters, and decimals, we keep it 3. Okay, let me choose the grid and CS, grid similar. If you choose any particular element or any family and you use that shortcut CS, then it will help you to create the similar element, right? So bear in mind, create similar CS. Okay, I think you have prior experience with Revit, I'm presuming that. And if you have so, then you must know that in Revit, families are like building blocks of your project. Modeling in Revit is all about placing the families in the proper place. And Before starting any project in Revit, you need to make sure that all the essential and all the substantial families are being preserved in your file or in your directories, so that when you want to model something, you don't need to get freak out, right? Actually, you can make your own customized family. Uh, there are three type of families, of course: system families, loadable families, and another is the in-place families. System families, these are the predefined families. Revit predominantly made such kind of families for you. Loadable families, you can make such families. As you can see, structural members like beams, columns, these are the loadable families. Also several architectural members like doors, windows, these are the loadable families. And in place families, like when you are modeling something and you saw you don't have that family preserved in your directory in that moment, and in order to tackle such situation, suppose you need a furniture in a place and you don't have that furniture preserved in your file or in your directory, then you can use that tool of in place family to create such families. Yeah. So, and the system families, I forgot to give you some examples, like the slabs, staircase, uh, curtain walls, partition walls. These are the system families. You cannot make these families. Revit made this for you. You are only allowed to add extra layers, regulate the thickness of these layers. You are allowed to do such things, nothing else. So yeah, this is all about three type of families. Okay, and I was creating the levels, and this will be 0.150. The peak lines. Place the click the escape button to get rid of that command. This will be the typing. Alright. This level is the typing level. CS create similar. And underneath that typing level, there will be another level. It's called, and it will be the foundation level. Okay. That grid doesn't have any purpose. So CS create similar. 3.5, and of course the peak line. This is the first floor, this is the second floor, this is the third floor, and then above the third floor there will be roof. It's going to be an offset of 3.5 meter as well, and above that there will be top roof, and the top roof, it will be placed 3 meter above the roof. Okay, now let me rename these levels. It will be first floor, then it will be second floor, This is the third floor. Roof. About that, there will be top roof. All right, all the levels have been created. Now I will link the CAD files. I have already shown you the CAD files. Actually, you have two options in your hand. Either you can link your CAD file, or you can import your CAD file. And there are some major distinguishments between importing and linking, because when you are importing a file, you are literally inheriting all the elements from that imported model to your host model. And among those elements, I mean, some of them are necessary, of course, some of them are unnecessary. And the unnecessary elements, they're large in number always. The unnecessary stuffs, they impose burden over your project, which hamper your project performance. So linking is more preferred in professional practice. And in my first video, I imported the CAD file because you saw all my plans were being densified in a single TWG file, which was a great burden for me. Later, I had to drafted the plan to each and every individual levels, seeing that single DWG file, and it was really time consuming. That's why the length of my project became pretty big. I mean, I mean, the duration of my project got really big. And okay, so now I will so here we have each and every plan which are being individualized to a separate CAD file or DWG file. So in this project, I'm going to show you how you can link your CAD file. All right, as you can see, I have already opened all the plans, structural plan views. So now let me go to the insert ribbon, and underneath that insert ribbon you can see the link option, and to that link option I'm gonna choose the manage link. Here the CAD formats. Now let me add the CAD files. Yeah, so the CAD files are being located here. All right, the course folder. FL, the first plan, as you can see, FL stands for foundation level, of course, and current view only. Preserve I want to keep it millimeter and center to center. Okay. So the foundation level plan has been linked to the foundation, I mean structural plan, foundation plan. It has been linked the FOL DWG file. Okay. Then we have to link them individually to their corresponded plans I have made. So auto center, yeah, slab on grade, slab on grade, SOG, center to center. Now the first floor. Here's the first floor structural plan. Now the second floor structural plan. Here's the plan for the roof, which has been linked to the roof plan. Now the top roof, manage links. Okay, TR top roof. So all the plans have been linked. I mean, all the DWG file have been linked to their correspondent levels. And okay, all right, I have set up my project. I have linked all the CAD files. I have created the project parameters. So all these things are being done. Now I want to get focused on the modeling. And before starting the model, let me explain you the chronology of work I am about to do in this model, in this modeling part. At first, I will place a concrete layer of 100 millimeter underneath the footing level, and that concrete part, of course, there will be placed underneath the footing, and above that there will be footings. And you can see there are several type of footings with different geometrical properties: 1600 by 1400, 1800 by 2700 millimeter. These are the dimension of the footings. So I'm gonna create these footing families and place them to these positions, and then there will be a column neck above the footings, and the column necks will be restrained through tie beams. And the function of these tie beams are pretty simple. If there's any lateral activities or any earthquake, then these tie beams, they will help to distribute the load over the entire structural frame in order to minimize the damages from the earthquake or from the lateral load. And then after creating the tie beam, I will place the slab on grade. I have already created a level for that, as you can see. Yeah. Sorry. I went to the architectural plan, but I linked my CAD files to the structural plan. So when I click to the architectural plan, slab on grade, the CAD plan, it were not getting visible. By the way, so here it is. This is the slab on grade. Then I will place that slab over the grade level, and that slab is going to have a thickness of 150 millimeter, as you can see. And then I will extend the columns to the first floor level. Here's the first floor, and you can see there are a bunch of beams available over here, beams which will have a different cross section, B6, B5, B4. I will create all these beams and place them to the first floor, and you can see these hollow places. There will be beam system, I mean a bunch of beam system or girder system, or you can tell them joist system as well. Joist, they are small beams, beams with small cross-sectional property. Okay, a bunch of joist or bunch of small beams, they create a system at that system, and that system, it supports a slab. So there will be bunch of beam system which will support the slab, and that slab, it will have a thickness of 50 millimeter. Okay, and I will place the same thing over the second floor and over the third floor. Same beams, same joist, I mean beam supported or joist supported slab, they will be placed to the first floor, second floor and third floor. And at the rooftop, there's a different system for the rooftop. You can see B4, B6, B5. So I have to make a different arrangement here, and also I have to place the ribs or joist to these hollow places, and then we will place another slab of 50 millimeter. And above the roof plan, there will be a top roof plan, and here I will place a slab of 150 millimeter over the shear wall. Okay, I explained the chronology of work I am about to do in this part. Now, as I told you, let me start my modeling from the foundation level. Now I will place Alright, let me define the floor, the slab. It will be a slab of 100 millimeter, right? As I mentioned earlier. So here you can see in the structural ribbon and structure panel, I have options, and from here I supposed to choose that arrow underneath the floor option, and I'm going to choose the floor structural. Now this family, it's a generic slab of 12-inch. I want to make a duplication. Let me tell you one thing, when you work with Revit and you choose any certain family to work with, bear in mind you should always make a duplication. You should always use the duplicate copy of that family. You are not allowed to use the original copy. It should remain an intake as it is, because later if you work on the same family, you get the same thing and you make the duplication, right? So this is very important. Okay, 100 millimeter concrete slab, 100 millimeter concrete slab, and let me define the material. Concrete cast in place gray. I think I should go with that one. So here I will also make a duplication copy. With concrete material. Another duplication. Okay, 100 millimeter. Anything else? Actually, as I told you that slab, this is system families. As you can see, we have options right here. If I wish, I can insert several layers. This layer I want to push it up, and I can select whether it will be surface, structure, finish, or thermal air layer. I can select several function for this layer, and then I can also select the material, and also I am allowed to regulate the thickness, as you can see. So these are the advantages of system family. When you use system families, you can add modification or add several layers according to your needs. Okay, I don't need them, so I'm deleting it. And now, yeah, okay, anything else? No. Now let me get focus over the slab creation. Okay, before creating the slab, let me adjust the constraint. You can see levels, it will be in the foundation level, no doubt, but I want it to get 50 millimeter, 500 millimeter down, right? Yeah, so here we go. And these lines, as you can see, these lines, they denote the direction of reinforcement. As it's going to be a concrete layer, I have no intention to place any reinforcement beneath these concrete members, so I am not interested to choose any dimension right now. To choose any direction right now. Okay, let me take a look. These are the unique footings, right? F5, F7, F6, F2, F1. These are the unique footings. They don't have any repeated copy over here, so I want to draw the unique footings first. All right. And after drawing, all right, I choose the rectangular option for my convenience. As you can see, all you need just take it down from here to here. So the rectangular option, it's pretty easy in order to draw the footings. So all the footings have been drawn. Now I want to select that option. Yeah. And then let me go to the 3D view. There's the 3D view. And I want to bring the texture. I want to see the texture. So the shortcut option GD. And from here, you choose the select texture, apply. Yeah. So you can see the texture as well. So now let me select it and CS create similar. You can see this F4 footing, it's not unique. There are a lot of replication of this F4 footing. So what I want to do, I want to copy it, right? C-O, and place them where they have the the same requirement, right? See, if you struggle to find out the snap point, then you should press the tab and keep pressing it until you get the proper snap point. But here you can see I am getting the snap point without having any trouble. Okay, I'll see aspect similar, rectangular. Now F3. Yeah, and C. Oh, copy. Right, I have placed all the concrete layer of 100 mm, so I am making a check the alignment, whether they are aligned properly or not. Sometimes you will see that there are some displacement, they don't get aligned properly, and in such situation you need to fix the alignment. Either you can move your element or you can align it with the proper line, right? Okay, I think the alignment is done, but let me see. Yeah, remember I took a offset of 500 mm and it worked. All right, now I want to lock them. Of course they should get locked. All right, I have I want to lock them with the plan. Yeah, they have been locked. You need to lock your elements. If you don't do that, later it might get displaced from the position you placed it. So in that situation you might have to face some ramification, which is really bothering. Though you will have options in Revit to fix such anomaly, but it is going to consume a lot of time. So I always recommend to lock the element whenever, or pin the element whenever you place it, right? Okay, I have placed the concrete layer. Now I will be dealing with the footings. You can see we have bunch of footings, F1, F2, where's the F3, F4, okay, F5, F6, F7, F8, F9. All right, these 8 and 9, F8 and F9, this seems like continuous footing. They are the shear wall footing. So this type of footings, they are kind of different. So I will deal with them later, but before that I want to define all these footings from F1 to F7. So in the structural ribbon you can see isolated, and the problem is we don't have any family preserved for the footing. And what I need to do, I am gonna choose the family for my footing, and here we have a folder called libraries. Where is it? Here's the libraries folder, and I'm supposed to go to the English option, US, structural columns, foundations. All right, MCAP. Yeah, this is the footing rectangular. Okay, let me choose it. I selected the footing, and now let me modify the families. Let me create the families for these particular footings. The first footings, it's going to have the name F1, and that footing, it will have a thickness of 0.5 meter, and the width will be 1.6 meter. The length will be 1.4, and then okay, here we have F2. At first I want to define all my footings. Alright, I have another monitor right here, as I mentioned in my previous video, and this monitor, it helps me to look over the plans or other essential files. Let me show you. Here I am seeing the dimension of my footings. The PDF file is available right here, and okay, F2, and the F2 footing, it will have a width of 1.6 meter and a length of 2 meter. Okay, then the F3 footing. F3. The F3 footing, 1.5 meter width, length 1.8, and then F4 footing. F4 1.8, and that will be 2.7. There will be F5. F5. If we have 5 footing, 2 will be the width. What is it? 1.7, the length. F5, F6. F6, 2.8. Then it will be 2.7. F6, F7, the F7 footing. Oh, 3 meter by 4 meters, so 3 and 4. Okay, 3 meter by 4 meter. The F1, 1.6, 1.4, the F2, 1.62, the F3, 1.5, 1.8, then the F4, 1.8, 2.7, then the F5, 2 meter by 1.7 meter, F6, 2.8, F7. F7 will be 3 meter by 4 meter. Okay, cool. Oh, now I will place my footings, and okay, they are not aligned properly. I will align them later. Right now I'm just placing them. Because of the camera, as you know, I record the video using my mobile camera, so yeah, I pushed it back a bit. F6. All right. Then there will be F7. Right, I have placed all the footings. MV. Now I need to move them. Or I need to align them. I was struggling to get the point, to snap the point. That's why I pressed the tab button. So MV. The placement. The alignment is necessary. Should always align your members or your families in the proper position, right? Even here I can see the misalignment tab. Yeah, so placed properly. All right. What? Oh God. So the A4 putting CO, I want to copy it, right? So multiple copy. I just placed C or copy. C-O. So I pressed the tab button to snap the point. If I get trouble to find it out. Yeah. All right. I think. Yeah. The foundations have been placed. I lock them all. I have placed all the footings, and I'm almost done with the foundation level. Hey, I have already created the footings, and there I left two footings. These are the continuous footings, as you can see, SW1 and SW2 or F9 and F8. These are called the continuous footing, and these footings will be supported. I mean, the shear wall will support these type of footings. All right, now in order to create these footings, I need to create the shear walls, the structural, and let me take a look the dimension of the shear wall at DI. This short command, you can use it to measure the dimension of any particular element or the thickness of any particular element. So yeah, so here is wall WA. Okay, WA, this is the shortcut command for wall drawing. 200mm shear wall, and that wall is of course I will choose the concrete material and 0.2 meter. And height from the foundation level to the tie beam. Okay, WA, and the base constraint foundation level. Top constraint, I want to keep it tie beam. Peak line, finish face exterior. Right, I have placed the I placed the walls. You can see the wall. Also here another wall. Okay, now I will place the continuous footing. Bearing footing. And let me take a look. The dimension again, DI 1.8 meter. One 5 meter. 1 point 8. Okay, so here in the bottom of the far left you can see select wall to place wall foundation under. So this is the wall I'm supposed to select. I think my wall foundation has been placed. Yeah, so here it is. Oh god, I made a mistake. I had to make a duplication copy. And F9. Should be F9. And I'm willing to make another continuous footing, and it will be F8, and the width will be 2 meter. Select walls to place wall foundation under. So I'm supposed to choose that wall, and yeah, my footings, continuous footings with shear wall have been created. So 2 footings have been created. Now I will place the columns, and from the foundation plan, you can see we have 3 categories of columns: column C1, C2 and C3. And I want to create the families for these columns. Before that, I need to change the dimension of them. What is it? Okay, right, there's the C1 column and DIs. All right, three type of columns. So structural ribbon column, and the column we have here, you can see it's an I section. We need a rectangular column. So let me load the family. Structural columns, concrete. Here's the rectangular column. Let me open it. And now there will be three type of columns. C1, first duplication will be C1. So the C1 type, it will have width of 500 millimeter, and the height will be 253. Height is really 253, and so the column CL, you need to use these shortcuts in order to save your time. Okay, then there will be C3, and C3 will have dimensions of 0.25 meter and 4 meter, 0.25 meter. And then C2. Right, let me start with the C2 column first. I want to keep it height, and to the top view. Right, so the C2. Now let me align it. V. C4. All right. H C L C L M V right. I have created all the columns, all the C2 columns indeed. Now I will be placing the C1 columns, and here's the C1 column. What is it? Where am I supposed to place? Okay, CL. And it will be C1. What is it? MV. Oh. What is it? Okay. CO. It's been aligned, yeah. I am very allergic to these alignment things, because when I do something, I think I need to do it properly, so later I don't want to get involved with any other business with it. It is what it is. I have done it for once, then it will stay as it is, right? Here's the focus. Snap point. Any more C1 columns? Here we go. This thing, yeah. Alright, I have placed almost all the columns I required. CS. Let me choose the C3 column. So all the columns have been placed. WF HI. Okay, GG. Let me bring the texture. Yeah, great. Now this right now I am willing to extend these shear walls to the top slab. Okay, top roof, yeah, they're being extended. Okay, I created the beams, I mean the columns and the shear walls, and I extended them up to the top roof. Now I will be focusing over the tie beams, and here's the tie beam plan for the tie beam. You can see WF wireframe mode. We have a bunch of beams over here. So B1, B2, B1, B2, what else? B3, B1, B2, B3, and anything else? B1, B2, B3. Okay, 3 type of beams are available here. So let me go to the structure ribbon, and the shortcut for beam creation is BM. And you can see we have a beam and the shape is W shape. So I'm looking for rectangular shape beam. I need to load a family for this. Structural framing, where is it? Okay, here's the structural framing, concrete. Okay, this is the beam we are looking for, concrete rectangular beam. So let me choose it. Now I will make duplications. I have to duplicate 3 families. I have to modify 3 families for these 3 type of beams, B1, B2 and B3. So edit type, yeah, in my another window I have opened the PDF copy of my plan, and watching that I will create the beam families. Okay, B1, it will have breadth of 3 meter and height 0.5. B2, so here we go, B2. B2 B2.25, And B3 will be 200. B1 is 300 and 500. B2 is 250 and 500. And B3 is 200. And where is B3? B3 is 200 and 500 millimeter. Okay. Now I should start with the B1. There's the B1, and let me choose the big line option. And okay, there's the B1. Okay, now let me align them with the plan. Or what is it? Okay, now the B3. These are the B2 beams. So let me select the B2. What did I do? Will be B1. BM, the beam command, and B2. And here's the peak line option. This one, this one, this one, this one, this one. Anything else? Okay. Now the B3 decline. Here's the B3. Now the B1. Here's the B1. R. Okay. I want to extend it. What the hell? What is it? The okay. All right. Nice. So there will be B3. CS, create similar. P1. The P1 is then already placed right here. So there will be a B3. B3 and P. Okay. B3. CS. Okay, now TR. Okay. This payment needs to be a little bit and TR. So the B1. Okay. Yeah. So, okay, it's been done. Here I am struggling to place the tie beams. And I think I'm almost done with it. Yes. Placement of the tie beams. So, ladies and gentlemen, the placement of the tie beams GT. Okay, the placement of the tie beams, and here I'm done placing my tie beams. Now I will place the slab over the grade line, over the grade level. Okay, and that slab, okay, I think this thing I forgot to do. Okay, nice. There was duplication. And now all the tie beams have been placed. Displacement or anything. What is it? No. Okay, and I want to extend it up to this point. Anything else? Okay, now I'm replacing the slabs. So SB, shortcut command for slab, and it's going to be a slab of 150 millimeter. And let me fix the thickness 0.15 to the concrete material, no doubt. And right, now I'm placing the slab. Later I will make modification or changes according to my need. Placement of the slab has been done. Slab on grid. Okay, WF wireframe. Okay, I think I need to make an opening to my slab. I want to make it shaft opening because I want to maintain the same opening dimension to the above floors. Here we go. Another opening for the staircase. Does it require any opening? I'm making an opening for it. I will see later. Okay, let me make that opening first. Then L. Okay, L. What is it? Shaft opening. want to extend it to the roof. And same for that opening. I also want to extend it to the roof. And as you can see, the slab on the grate, the first slab I have placed here, I want to keep it intake. I don't expect any opening here, because there will be staircase right here. So if I open that slab, then this thing won't happen. I will be in trouble. Yeah. Okay. Okay, now I will create the slab to the first floor, second floor, third floor. And let me open the plan of the first floor. Here's the first floor. You can see we have a bunch of beams, B5, B4, B6, B7. So I have to define all these beams. And I will place them. All right. Let me see. First floor plan. In another window, I'm watching the plan, and before placing this beam, I have to create the families for them. So the shortcut for beam creation, BM, and we have some requirements here. First requirement is the B. The B beam, it will have a breadth of 150 millimeter, and then it will have a height of 0.25 meter. Okay, then it will be B4. Okay, the B4 beam, it will have a breadth of 0.8 meter and a height 250. Okay, and then B5 0.5 breadth, and height will be the same. Then B6 going to have a breadth of 0.6 meter, and B7 will have a breadth of 0.3 meter. Okay, these are the beams. Now I want to place them. It's the peak line. From here, let me choose. Okay, so the beam B. All right. So beams are been, when the B beam has been placed, CS. Now the B5. It will be P5 as well. MV. Let me align all these beams now. Okay, CS P7 decline P6. CS, pretty similar. Repeat the lines. Yeah, is it okay? And CS, create similar decline. V. Okay, and this part. Now I want to curtail all the beams. All right, the beams over the first floor has been created. Now you can see the hollows. These are the hollow spaces between the beams. So in these hollow spaces, I will place system of joist or a group of joist, which will help me to support the slab. Okay, and now uh, the joist. Let me take a look at the dimension of this joist. For this joist, they will have a cross-sectional property of 150 millimeter by 250 millimeter. I mean, there will be width of 150 and the height will be 250. So to place that system of joist, let me go to the structural ribbon, and from there let me select the beam system and sketch beams, and there will have a fixed spacing, and the spacing will be 550 millimeter fixed distance, right? And I want to choose the concrete rectangular beam B, right? Now I am supposed to place them. Should I start from here? Let me choose the rectangular option. Stretch it up to that part. And beam direction. Yeah. And, okay. These annotations, they don't have any purpose here, so I want to hide them by category. So I hide the annotation. Let me select it again. Okay, again, CS sketch beam. It's a bit of time consuming and might feel annoying to you because I'm gonna repeat same task over and over again to all these hollow spaces. CS 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 okay CS There's no shortcut to copy paste all these things. But I think if you use the shortcut tools and the shortcut command, then you can save some time, some amount of time, I guess. Okay, we forgot to place a beam right here. Yeah, so it's been placed. I want to align it. Okay, oh, yes. And one more left. The direction. Yeah, so the joist system or the beam system has been created. Now I will place a slab above it, and in order to place the slab, SB is the shortcut command. And this slab, it will have a thickness of 50 millimeter. Okay, I think I should I go with the 'Here it is. Now let me select the peak line option. R. R. Okay. The slab has been created. Here it is. Now I want to replicate the same thing over the second floor and the third floor. In order to do so, I am supposed to select the structural framing, framing other joists, structural columns, the floor only. So yeah, see, I selected all these floor related stuffs in the first floor. And now I will copy to the clipboard and align to the selected levels. I'm supposed to choose the second level and the third level as well. Let me see. It's taking some time. I think I should change the configuration of my computer. Okay, I have created the slab to the first floor and also replicated the copy. Okay, WF wireframe, and you can see we have some partition walls right here, and this partition walls WA, there will be architectural walls, so wall architecture, generally 8-inch, and I supposed to make it 100 millimeter partition wall. PW stands for partition wall, right? Okay, 0.4 meter. All right. Okay, I will choose the peak line option, finish face exterior, and then first floor to second floor. Okay, middle. Anything else? Okay, the partition walls have been created. Now I will place the slab over the roof, and you can see the plan of the roof where we have some beams B4, B5, and what else? B6, right? B4, B5, B6, and B. Okay, let me define all these beams first. So for beam creation, the shortcut is BM. I want to name it B4. B4 does it exist? Yeah, it already exists. Here's the B4. Here's the B5. And B6. Alright, all these families are already been, all these families are already been preserved in my directory, so I don't need to create any family individually. All I need to do just choose and place. So at first the B5, and the B5, let me choose the big line option, B5. Here we go, B5. B5. Yes, L. Just got it. Right. Okay, TR. R. Here will be the B6, the big line option. TR. MV. So in the middle there will be B6, and in that direction there will be B4. And what else? CS, create similar peak line. Here it is. And then B4 peak lines.
Right, I have created the beams to the roof level, and okay, structural ribbon and the structure panel. I supposed to select the beam system and sketch beam system. Yeah, pick the rectangular option, and from here CS. Interaction. CS, sketch beam system. In direction. Oh, right. CS, sketch beam. Beam direction. CS, sketch beam. Okay, this thing. Shouldn't be here. CS, sketch beam, rectangular option. Here to here. CS, sketch beam system. Yes, sketch BIM. It's the direction. Okay, now I will place the slab SB 50mm slab. I want to draw it from here and stretch it till to the end right here. Okay, so the slab has been created, nice and perfect. By the way, and I want to go to the top roof, and as you can see, at the top roof we have to place a slab of 150mm SB 150 rectangular option. Now let me just drag it, and here we go. Don't attach. Let me take a look over the 3D model. Yeah. Okay. I have almost created all of my structural elements except that staircase. And that staircase I am willing to draw right now. And I want to draw a monolithic staircase, and that stair it don't have any railing, because railings are considered as architectural member, and as I promised that I don't want to keep any architectural elements in that project. So yeah, let me get started first, and before that I need to make a count how much riser there will be, right? So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Oh yeah, there are 20 lines, and for the 20 lines there will be 19 risers. So yeah, so here we go. The riser will be 19, and slab on grade to the first level. Okay, so I want to create a sketch, and in that process at first you need to define the boundary, the boundary line of your stair. So I choose the option peak line, and now I'm gonna define the boundary through picking lines. Yeah, so TR. And the riser will be, choose the peak line option again. This is the riser. Just let me keep going. Now let me define the stair path. Yeah, I have defined the stair path. Let me go to the 3D view. So here's my stair. Relative height. Alright, I will create the staircase now. And before creating the staircase, I need to make a count how much riser there will be. And let me count from here. You see this thing here. It's not a part of the staircase, right? So my riser will be started from here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Right, there will be 20 riser. So okay, I counted 20 and I want to keep one riser less, so I gave it 19. And now let me define the boundary for the stairs. Let me trim the dr. Okay, I defined the boundary. Now the riser. Okay. So there we go, and now I want to define the stair path. Okay, the stair has been created. Now let me take a section. Here's the section option. Let me go to the view, section view. Extend it a bit. And you can see there's some inclinations. These are called nosing. And I don't expect to keep any nosing in my staircase, so I want this inclination to get planed. So in order to do so, let me go to the edit type, and here you can see run type. We have 3x4 inch nosing. I don't want to keep it, so I want to make a modification. Zero nosing, it will be 0. Structural depth, I want to keep it 150 millimeter. Yeah, it's done. Okay, now I want to replicate this stair up to the roof. So first floor, second floor, third floor. I want to make a copy and align to the selected levels. First floor, second floor, third floor. Okay. So my stair, I have aligned my stairs. Replicated my stairs up to the roof. I might have make multi-storied stair here, but the problem is when you make multi-storied stair, you cannot select individually. But here, when you make replication, you can select individual stair and make modification or editing according to your need or to the preference of the architect or the structural engineer. All right. Let me go to the 3D model. Here we go. Now these things, these columns, I want to set the top level up to the third floor. And these columns, the top level to the roof. Okay. So these columns the roof. This one also up to the roof. Okay, here we go. Alright, I have created the structural members. The first part of my project, it's done. As I told you that in the first part, I will show you the concrete modeling, and I have created the geometrical shape of every structural members. And in the second part, I will show you the rebar fabrication, where you will have a clear perception about the rebar detailing. You're gonna see how I place the reinforcement beneath these structural members. Hope you have enjoyed the video. Thanks for watching. Alright, I completed the concrete part, the first part of my project. Now I will be emphasizing over the visibility graphics. As I told you, and if you can remember, at the very beginning of my project, I created two parameters. Uh, One I named it as concrete parameter, and another was the river location. So using that concrete parameter, I will filterize each and every element of my model, of my structural model, and I want to filterize them and add them to my visibility graphics. Okay, here we go. And the filterization, I want to do it from that. Okay, I want to do it from the 3D view. Before starting it, let me turn off the levels from the 3D view. And here's the levels. I want to turn it off. Okay. I want to start the filterization from the base. Now let me filter the selection. So the floors. And I want to name it 100 millimeter CC layer. CC stands for concrete, right? I hope you understand this shortcut form. Let me go to the visibility graphic. Now I want to add a new filter, and I will name it, and I want to maintain the chronology, the proper chronology. That's why I will number each and every filter. So it will be 100 millimeter. Oh, my typing skill. Right. 100 millimeter CC layer. The category, it will be in the floor category, and concrete location equals to CC layer. And I want to turn it off. Now I will select all right. There's a mistake I can see. Structural foundations. Right, I will fix it later. Now let me get focus over the filterization. So the foundations now. Let me go to the visibility graphic. And from here I add new so it will be structural foundations, concrete location equals to foundations. Okay, let me add it to the filter now, and I want them to disappear. Oh, this framing, they shouldn't be here, so I deleted them all. I don't know how did it came. Alright, when I made the replication to the upper floor, then this meshing had been happened. Foundations. Let me get to the structural foundations. Concrete location equals foundations. Apply. Okay. All right. Now the column necks. And among this column necks, there are shear walls, and I want to avoid these shear walls. Actually, I want to filterize all the columns up to the roof level. So I will name it as columns. Equals to columns. Apply. Okay. We add them. Yeah, taking it down. Now the shear walls. Do I need to filterize them? No. No filterization is required for selection. Shear walls ASW. Okay. Shear walls, it will be in wall category, and there's no option available for structural wall, because structural wall will bear the load of the structure, but walls mean there might be architectural wall, like the partition walls. They are the architectural wall because they deals with the space and aesthetic. They literally don't bear the load, or maybe they bear a very small amount of load. Okay, wall category will be fine. So okay, and let me turn it off. Apply. Done. Okay, now the tie-beams. Tie-beams. L. Structural framing. Okay. Add new and 5. Tie-beams, structural framing. Here's the structural framing. There's no individual option for beam for this beam, so structural framing will be the category of it. I mean, beams, they work as a part of a structural frame, and they don't only define the structural frame. I mean, there are, of course, other members in this framing system, like the columns or the slab. It also works as a structural frame member. Uh, so the I-beams apply. Okay. Number 5, let me put it down. Apply. Okay. Now this slab. And what is it? Slab. Great. Slab on grate. I want to add it as number 6. Slab on grate, and it will be in the floors category, and concrete location equals to slab on grade, of course. Apply. Okay. In the down. Slab grade is there. I named it. So go to the visibility graphic and add it. 7. The name doesn't seem okay. It will be stair on grade. Stair on grade. Here's the stair category, and the concrete location equals to stair on grade. Okay. Beams at first floor. Beams at first floor. So beams at first floor. There are 2 type of beams here. Structural framing, of course, and the framing system. Structural beam system. This 2 option. I want to select concrete location equals beams at first floor. So apply. Okay. Right. slab and first floor. Slab at first floor. Slab at first floor. Where's the floor option? Still. Stair at second floor. Stair at second floor. Let me add it. It will be number 10. Stair at second. Okay, stair at second floor. And here's the stair option. Somewhere. Yeah, here it is. And it's supposed to be concrete location equals to stair at second floor. Will it be second floor or first floor? Yeah, I want to rename the filter by okay. Okay, now antique. Set it at the bottom. So the walls, partition walls at first floor. Partition walls at first floor. And okay. Partition walls at first floor. Partition equals walls at first floor. Apply okay. Let me add it. Now just put it down. So yeah, it disappeared. Soft openings. I want to filterize it as well. Should I filterize it? I'll just keep it. Structural framing, joist and others. Beams at second floor. Beams at second floor. Beams at second floor. And now structural framing and structural beam systems. From here I want to select the concrete location equals to beams at second floor. It will be alright. Okay, this thing must put it down. This will be slab at second floor. Slab at second floor, number 13. So floors, concrete location equals to slab at second floor. Okay. Mistakenly, the stair at first floor, I said the concrete location, the same name, so that's why I put a spacing right there. Second floor. So the stair option, there's and beams at third floor. Okay, beams at third floor. Beams at third floor, and from here structural framing, structural beam system, and concrete location equals to beams at third floor, right? Same name. Supply. Okay. Slab at third floor. I mean, in structural discipline, that vocabulary slab is more popular, cause slab means it will have reinforcement beneath this element. That's why in the field of structural engineering, it's called slab, but the architect, they call it floor. Anyway, it accomplishes both purpose, structural purpose and the architectural purpose as well. Slab at third floor. Okay. Here's the floors category. Concrete location goes to slab at third floor. Like, okay. Stair at third floor. Stairs at third floor. Concrete location goes to beams at roof level. Beams at roof. So for the beams, I supposed to choose the structural framing and structural frame system. Then concrete location equals to what? Beams at roof. Right, so this thing must be put in the bottom. Apply. Okay. Here slab at roof, visibility graphic. Slab at roof, and the slab will be in the floor category. Concrete location equals to slab at roof. Okay, apply. Okay. The bottom. Here this beam, this slab will be slab at rooftop. Slab at rooftop, visibility graphic. Slab at rooftop. So it will be floor concrete location equals to slab uh, at rooftop. Apply. Okay. This. All right. So I have filterized all the stuffs that I created. Now I turn off the visibility option. Now I want to turn them on one by one. Let me turn them on. All right, they all reappeared again. All right, this is all about the filterization of the structural elements.